Hello again, everyone, and welcome to another lesson in our Introduction to Java Programming series. And today's an exciting one because today you're going to be given the tools in order to really up your programming game. Thus far, we've talked about being able to get input. Remember the IPO model? We've talked about being able to get input. We've talked about being able to do output. And we've talked about some of the useful operations that you can do, rounding, modulo, arithmetic operations. And the last topic that we talked about was this idea of Boolean expressions, trues and falses. And so if you remember, we talked about things like being able to say A equals 1. And how this expression here evaluates to either true or false. In the Java programming language, and one of the things I tried to emphasize is that you really need to memorize some of those operators. So this, for example, not the single equal, but the double equal is the way that you can do a comparison. Is this equal to that? We talked about some of the regular math type of things. We also talked about the exclamation mark being used for not. A is not equal to. But the trickier ones, and the ones that are going to come up today a little bit, is the ability to combine those things, to be able to use ands and to be able to use ors. And the operators for those were the ampersand, which I can never draw properly, or the pipe symbol. So that would be one, and that would be the other. So today's topic is building upon that. So right now, if you need a quick refresher, stop this video, go back, have a look at your lesson or the previous video, and make sure you're really comfortable with this idea of being able to make an expression that evaluates to be true or false. Because today's topic is all about decisions. A very famous mathematician and computer scientist named Dijkstra once looked at structured programming, which is what we're learning, and determined that all of the programs you've ever seen and all the programs you ever will see all require just 3 programming elements. And with those 3 programming elements, you can essentially build everything that you can build in a structured language. One of those elements was the ability to do commands in sequence. And you've learned that. You know that you type commands into Java, they get executed one by one, and then the program ends. There are 2 other important features, and one of those is the ability to make decisions, the ability for a computer to branch off and decide on one road or another before then continuing and working in sequence again. That's what you're going to be learning today. You're learning that second of the 3 key programming features. The third one, by the way, is repetition. So the ability to have loops, or the ability to repeat code without having to sort of type ad nauseum. And that's coming very soon. But today we're focusing on decisions. And in the computer world, the idea of making decisions sometimes has different names. You'll hear people talk about it in different ways. Sometimes they're called conditionals because based upon a condition you're going to follow one path or another. Sometimes you'll hear them called if statements, and that's just because in many languages that's the key word that's used. And sometimes you'll also call them switches, and that's just another key word that's often used in programming languages to be able to make those decisions. As it turns out in Java, there are 2 kind of ways that we often use in order to make those decisions. And the first of those is called an if statement. And so let's just jump really quickly to see what's happening in a program. So what's happening in a program when you make a decision is that the program is following a sequence, step-by-step instructions, and then you are going to give it some sort of a decision to make. And that's what you learned in the last class. So is A equal to 1? If it is equal to 1, it is going to follow a different sequence of instructions. It's going to branch off and execute all of the instructions listed here before it then joins the program and continues on. On the other hand, if this is not true, then it will go and follow a different path. Eventually, both of those paths meet up again, either at the end of your program or to do some other code after the decision is made. But in the meantime, your code has a choice to follow, and it's only going to follow one of those branches. It is possible to have decisions that are more complex. So instead of having just 2 branches, potentially having 3 branches or 4 branches or 10 branches for the computer to follow. But the essential structure is that your code is executing in sequence, and then it's either going to start executing on this side or it's going to start executing on this side. And at some point, those two will come together again in order to meet. So what does this look like in Java? And there's a great illustration that I found of how this looks when you're actually writing programs. And this here is the simplest form of a decision. It's called an if statement in Java. And you'll see here that there's a certain keyword. And this is a keyword that identifies that you want to make a decision. And that keyword is if. The if is followed by brackets. And what goes inside those brackets is the decision that you are trying to make. So again, going back to our simple thing here, I would say if A equals 1. And you can make that as complex as you need to. It could be A equals 1 or X equals 2 and R is greater than 4. Okay, so that's an example of making this condition complex. But remember, as we talked about, that this is always going to evaluate into a true or a false, regardless of how complex you make it. If it's true, it is going to execute all of the statements that are inside these brackets. So you can think of these curly brackets as like your scope. They're defining what statements are going to belong in that branch that you're taking. This next keyword is optional. So you can make a decision just with this first part and nothing else. And so what would happen is that if it's true, it will follow this other branch. But if it's not, it's just going to continue executing the code as normal. This else here is giving you an option to say, well, if it's not true, then this is what I want to follow. These are the steps that I want to follow. And so you'll see that the key words here are if and else if. You can see that your condition falls in here. Else doesn't have a condition because it's the catch-all, right? If that's not true, else is always going to be the thing that you follow. But this is only going to happen when this part doesn't. It's kind of like an either or situation. It's not going to do both. The other thing that you're going to notice, and this tricks up beginners a little bit, is that I've hammered home the point that every time you write a statement in Java, you have to put a semicolon at the end of it. You can see it here. Oops, you can see it here. You can see it here. If statements don't have a semicolon, and that's because the best way to explain it is that it's not really doing work, right? It's not performing an operation. What it's doing is it's making a decision so that you can decide which branch to follow in order to do your work. And so because its purpose here is to make that decision, the semicolon isn't used. There's a bit of a catch, and I'll explain that later, in that you could have a semicolon there, and Java will not necessarily get upset with you. You're not going to get a syntax error, but your program isn't going to behave the way that you want it to. And so that's why it's really important to kind of remember, jot down a note that you don't put semicolons on these ifs and else pieces. So I've jumped into NetBeans here, and the best way to really see this in action is to actually do some typing. And so we're going to do a fairly classic example illustrating if statements. And in order to make a useful if statement, you are going to need to have some variables. Now, it is possible for me to create an if statement without variables, and it would look something like that. There are these keywords in Java called true and false, but that's not very useful because it's not really making a decision here. It's always going to follow this branch because it's true. I can also make silly statements like 1 equals 1, which again is always going to be true or always going to be false. But you can sort of see the structure here. We talked about this if statement. We talked about having some sort of a condition in here and then some sort of structure. And then alternatively, you can have an else. The one piece I didn't show you, and I did kind of allude that this was possible, is that you can have multiple branches. And the way that we do multiple branches is with these keywords else, if. And so else means, alternatively, if this is false, then I would like to do another check. And so I would have some other statement here. And so you can see that I could have as many of these else ifs if I want. I could have 100 different branches if I would like to have them. The key here with this type of a decision is that Java is going to execute them. It's going to look for them in order, one by one. And the first match that it finds is the one that it's going to follow. And it's going to ignore any other branches after that until it gets to the end. And then the code continues normally. So how do we make this useful? Well, we need some variables to make this useful. So let's say we have an integer representing grade, someone's grade in one of my courses. So we could then assign a letter grade based on that as a decision. And so what we could do is we could say if grade is greater than 85, then what we're going to do is we're going to print something. You have an A. Excellent. Well done. Otherwise, we want to potentially have some sort of a grade in between. So I could say else if grade is greater than 65. And we could put something else here. And then any other grade is going to be captured in this statement here. And we'll just call this a C. So this was the way that I've structured it. We could certainly run it if we wanted to. And it would, hopefully as you would expect, say that this student has an A. And if I were to change this to be something else like 70 and we were to run it again, you would now have a B. Now this works because of what I mentioned about the order in which Java executes. It first looks here to see if it's greater than 85, which means that if I have a mark of 90, let's say, it will execute this one and skip all the others. But notice that if I decided to change this and I put 65 here and 90 over here, and let's say I have a grade of 90, you want this path to be followed, but it's not going to, because Java follows the first path that matches, and that's this one here. So you have to be really careful with the way that you structure your if statements. If I wanted it to go in this order, then I would probably need to have something more complex. Like, for example, if grade is greater than 65 and grade is less than or equal to 89, right? Or less than 90. And now I've constrained that case a little bit more, so it will behave a little bit better, hopefully. Notice that I had two separate ways of writing that over here, and you have to really be careful when you're constructing your if statements to make sure that there aren't any overlapping conditions. and that you know where one range ends and where the next range begins. So this is a very straightforward example of how you would use an if statement. It can get as complex as you want in here. Remember some of the dangers that that I warned you about. So let's see. If grade equals 80, then I want to say c.print line. I don't know, you fail. Just cuz. So what I would expect here is that this is only going to print when the grade is equal to 80. So let's go ahead and run this program. The grade is 90, and yet it still says you fail. And that's what I highlighted before about this semicolon. Right? If I do a semicolon in there when it's not supposed to be, the way that Java is interpreting it is that this semicolon is the one line of code, the one piece of work that you want to happen if this is true. And this is basically just a no operation. It's an empty operation. And so what happens is when the grade is equal to 80, it's going to do nothing. And then it's going to continue and execute your code all the time. So please be cognizant and careful of that semicolon when you're working with if statements in this way. So at this point in the course, there's a little kind of few tidbits and nitty-gritty details that that you probably need to learn. So let's just get rid of this. First thing, as you already saw, is that an if statement isn't something that you can only have one of. So you can have multiple decisions inside a program. That also means having decisions inside decisions. So in other words, you can absolutely have another if statement inside your one if statement. And you could have another one inside that, and you can have another one inside that. It gets very confusing when you start to do that. And so many people would prefer to kind of make a more complex condition out here. The reason it gets confusing is, of course, you're now going to have brackets within brackets within brackets. And so whatever development environment you use, make sure you use the nice auto format, which will help to indent and help you visualize what is happening. The other thing is, you probably saw when I was typing that these brackets that we use are sometimes optional. And what that means is that if I only have one line of code that I want inside this if statement, I can potentially leave those brackets out. Right? I could even do that over here if I wanted. I could leave the brackets out of there and it would still work. The problem is that that only works for one line of code. If I then decide, oh, you know what, I really wanted to add something else to this, now I've broken my program. And I've broken my program because when I don't have those brackets, the only thing that belongs with this else if is the one line of code. So the bit of advice that I give you is always put in brackets around. Even if it's only one line of code, always put in brackets. It can make it a little confusing, but in the long run, it can really help you out. So that's called nesting. It's a technical term for it. It's called nesting in order to do that. And then the last thing I wanted to talk about today was this idea of scope. And scope means when you define, let's say, a variable, how long does that variable exist for? You know that when you create a variable that it's reserving a spot in memory and allowing you to assign a value for it. And thus far, when you've created a variable, that variable lasted for your whole program. Now that you're getting into the ability to make decisions, you're also potentially going to run into some problems where your variable that you created doesn't exist anymore. And that's because a variable has a defined scope, a beginning and an end. And again, that's where these kind of curly brackets come in handy. You know, when I create an int grade equals 90 here inside my main program, it is going to last all the way till the end of my program down here. The problem is that that's also true inside if statements. So for example, let's get rid of a bunch of stuff here. Let's imagine that in this if statement, what I wanted to do was actually just assign a character grade. And so all I really wanted to do is to say, int C grade equals A. And so I've created a variable, and then later on when I'm done with my decisions, I just want to print that to the screen. Nice and easy program. The problem is that I have an error. I have a syntax error, and the problem is you can see cannot find the symbol. And the reason for that is that when you declare a variable inside an if statement, inside a smaller scope, that variable only exists within this scope. As soon as that if statement is over, the variable is gone. You can't access it anymore. That area of memory you reserved is freed up for other uses. It's gone. And so if I wanted to do something like this, I would have to make sure that I actually define that variable outside and then only changed it inside the method. Okay. Here I still have an error just because of initialization. Remember how we talked about default values? And so if I wanted to make sure that this was good, I could have an else statement, which would help to address that. Or I could always just give this a starting value, some sort of a default value to work from. Okay, so that's an introduction to decisions in Java, and you should probably take some time to actually try one or two statements yourself first. And then our next lesson is going to come back and look at another way of making decisions in Java, as well as dealing with any questions that have come up in the meantime. Hope this helped. Hope this allowed you to increase the power of your programming and given you the ability to make decisions and your code to be able to make decisions. And I'll see you next time.